Algebra Honors, we're going to warm up our Unit 6D9 with some practice with exponents and radicals. And so what we're going to do is simplify each of these expressions that we see on these first problems. So I need to remember my rules about simplifying. I know that I can't have any factors inside the radical that are perfect squares if I'm taking the square root, or perfect cubes if I'm taking the cube root. I cannot have a fraction inside a radical, and I can't have a radical in the denominator. Things that I need to remember when I have exponents, I don't want to have any negative exponents in my final answer. So the square root of 18, x7, y14, I'm going to rewrite this so that I have a bunch of perfect squares. That's going to be 9 times 2 times x to the 6 times x times y to the 14. Now I can see all my perfect squares, and I'm going to pull them out. The square root of 9 is 3. That's done. The square root of x to the 6, I'm going to pull that out and say x to the 6 divided by 2, so it's x to the 3rd. That's done. And then I have y to the 14. When I pull that out, that will be y to the 14 divided by 2, so it's going to be y to the 7. I couldn't take the square root of 2, and I couldn't take the square root of x there, so I'm going to still have the square root of 2x in my final answer. Double check and make sure my radicand looks like it's as simple as possible, and it does look like that. Okay, over here I need to remember all of my exponent rules. So I am going to multiply this outer exponent times all of the inner exponents. Remember, this 4, you can't see it, but it has an exponent of 1. So I'm going to multiply 1 times negative 3 there. I'm also going to multiply that outer exponent times the 2 in m squared. So when I do that, I have 4 to the negative 3 times m to the negative 6. And that's all times, over here, negative 2 times m cubed. Okay, since I'm multiplying straight across, I remember that when I multiply, I keep the base and add the exponents. So for now, I'm going to say that I have 4 to the negative 3. I'm not doing anything with that one yet. M to the negative 6 times m to the 3rd is going to be m to the negative 6 plus 3 is going to be negative 3. And that is times negative 2. Right? 4 to the negative 3 is right here. M to the negative 6 times m cubed is m to the negative 3, and I'm still multiplying times negative 2. Okay, now I need to deal with these negative exponents. So I know that if this is all over 1, just because I'm going to have a fraction in the end here, anything that has a negative exponent is going to move. Anything that has a negative exponent is going to move. Okay, negative 2 has a positive exponent, right? So it's going to stay right where it is. My final answer is negative 2, still in the numerator, over 4 to the 3rd times m to the 3rd. Remember, once we move that element that has a negative exponent to the new location, it has a positive exponent. Okay, and now I can simplify. So why don't I take up a little less space there, and I'm going to say that this equals negative 2 over 4 times 4 is 16 times 4 again is 64 m cubed. But haha, I know I can simplify that one more time, so that's going to just be negative 1 over 32 m to the 3rd. Sorry, I'm encroaching on my next problem there. Okay, here, you know what, I think I'm actually going to go ahead and give myself positive exponents first, and then I'm going to deal with simplifying. So I'm going to move anything that has a negative exponent down, anything, or up, depending on where it is, right? So this is going to be, I'm going to keep n squared on the top, okay, and I'm going to move 7 to the 1 down to the denominator, m to the 1 down to the denominator. Looking in the denominator, I have m to the negative 3, so I'm going to move it up. Now it's m to the positive 3, and n to the 5th is going to stay right where it is because it has a positive exponent. So I moved 7, I moved m, I kept n squared, I moved m up, and then I kept my n to the 5th. So I'm just double checking to make sure that I dealt with everything, and now I get to simplify. Okay, so n squared over n to the 5th. I'm going to say that's n to the 5 minus 2. It's going to be n to the 3, and my bigger exponent was in the denominator already, so I'm going to keep n to the 3 in the denominator. Okay, I did n first just because that's what I had on there. m to the third over m to the 1. It's going to be m to the 3 minus 1. It's going to be m squared. And I keep m squared wherever the bigger exponent started out, so I'm in the numerator. Those m's are taken care of. And then 7 is still in the denominator. It had a now it has a positive 1 exponent, so it just stays right where it is. So that should be my answer, m squared over 7n cubed. And here, I just always have to remember I'm distributing to everything inside the parentheses. So 3 has a positive 1 exponent, right? I don't want to miss it. And also x has a positive 1 exponent. So I now have 3 to the negative 4, x to the negative 4. And of course I want to write that with positive exponents, so it's going to be 1 over 3 to the 4th, x to the 4th. 3 times 3 is 9, times 3 is 27, times 3 again is 81. So that's going to be 1 over 81, x to the 4th. Okay. All right, order of operations. I got to take care of this outer exponent first before I can do any of that multiplication. I see already that I'm going to be able to simplify, but I'm just going to take care of this first. Okay, this is negative 1 times x squared, yeah? Luckily, negative 1 cubed, it doesn't really matter because it's still going to be negative 1. But I am technically distributing that outer 3 to all of the exponents inside. Okay, so for now, I'm just going to do one step at a time. This is 8 times negative 1 x to the 6th. That's because negative 1 is negative 1 cubed. It's the same thing, right? Negative 1 times negative 1 times negative 1. Okay, this is all over negative 24 x to the 4th. So negative divided by a negative is a positive. And I have 8 goes into 8 one time, and 8 goes into 24 3 times. Okay, so I have 1 times x to the 6th. This is just positive 1. It's not plus 1. Okay, 1 times x to the 6th. So my numerator is x to the 6th. My denominator is 3x to the 4th. And I'm going to simplify that. X to the 6th over x to the 4th is going to be x to the 6 minus 4, which is x squared, over 3. That should be my final answer. Okay, there are a couple different ways that I could have done this. I could have said 8 over negative 24 is 1 over negative 3, and then simplified after that. But this should be my answer. Okay, and finally, 3x to the negative 2y all over 5x to the 4th, y to the negative 2, z to the 0. Well, poof, that's 1. That's getting out of there. All times 9 to the negative 1, y to the 3rd over x, y squared. Woof. So I think the first thing I'm going to do is get all of my exponents to be positive. Okay, so this is going to be 3y. I've taken care of the 3 and the y. Times, still in my numerator, I'm going to keep that y to the 3rd. Okay, I'm marking out things that I've taken care of so I don't lose track. In my numerator, I'm going to bring x to the negative 2 down. So now that's x squared in the denominator. Also 9 to the negative 1, I'm going to put that in the denominator. That's taken care of. Now let's look at what we've got going on in our denominator. I have a 5 that gets to stay down there. I have an x to the 4th that gets to stay down there. Y to the negative 2, I'm going to move it, right? Y to the negative 2 is going to come up top. And I have x and y squared. Those both have positive exponents, so they're going to stay down. Okay, so, let's see what kind of simplifying we can do. Look at this. I have y squared and y squared. Those are gone, right? Anything divided by itself is 1. And I'm going to say 3 divided by 3 is 1. 9 divided by 3 is 3, so I'm changing that. Okay, in my numerator, I have y times y to the 3rd, so I have y to the 4th. In my denominator, I have a 5. I'm going to put my number first, my coefficient first. Oops, times 3. I guess I'll write that like that because I almost missed that 3. X squared times x to the 4th is x to the 6th. Times x is x to the 7. Okay, when I simplify one last time, I get y to the 4 over 15x to the 7. Y to the 4 over 15x to the 7. Okay, so that was practicing all kinds of skills that we had from the earlier part in our unit. So more recently, we have been practicing our adding and subtracting radical expressions. So remember, the first thing we want to do is make sure that everything is as simplified as it can be. Each term has the simplified radical. And then, in order to add or subtract, we want to make sure we have exactly the same radicand and the same index. So I have 3 roots of 7 and 2 roots of 7. That is the way I say it. It's 3 times the square root of 7 plus 2 times the square root of 7. But the way I think about it is if I have 3 of these and then I have 2 more of them, I have 5 of those things, right? 5 of those roots of 7. So you're going to add the kind of coefficient first and then keep that square root of 7. You are combining like terms, and the square root of 7 is alike with the square root of 7. We're allowed to combine things that have that as the main factor. Okay, so 7 times the square root of 3 minus 4 times the square root of 3. I have 7 of them, and I'm going to take away 4, so I only have 3 of them left, 3 roots of 3 left. Okay, 7 minus 4 is 3 times the square root of 3. So here I don't have the like terms right this second. I don't see like terms. I have to turn them into like terms if I can. I'm going to make that be the square root of 16 times 2 plus 2 times the square root of 2. 16 times 2 is 32. So now I know I have 4 times the square root of 2 plus 2 times the square root of 2. So if I have 4 of them, 4 roots of 2, and then I add 2 more, I have 6 times the square root of 2 total. Suppose I can box in all of my answers. Okay. So now we have 3 terms. Let's see what we can combine. Square root of 18 I know is really square root of 9 times 2 minus 6 times the square root of 3 plus 5 times the square root of 2. So this is 3 roots of 2 minus 6 roots of 3 plus 5 roots of 2. And so I'm looking for like terms, that guy and that guy. 3 of those and then 5 more of those. I have 8 of those roots of 2. Minus 6 times the square root of 3. I can't actually do any more combining because I don't have the same radicand. And nope, not finally, second to last. 3ab, 3ab, 3ab. All my radicands are the same. All my indices are the same, right? And so I have 5 minus 2 of these. 5 minus 2 is 3. Then I add 3 back. So I have 6 total 3ab roots. Right? 5 minus 2 is 3, and then plus 3 is 6. I have 6 of them. Okay. And cube root of 3x plus cube root of 3x squared. Super close to being able to do something with that. But I don't have the same radicand, right? I have the same index, but I do not have the same radicand. So I'm going to just leave that as the square root of 3x plus, excuse me, that's the cube root. The cube root of 3x plus the cube root of 3x squared. Much as I want to be able to combine them, I cannot. All right.